All right, we are going to go over the now you try questions from the notes from so it's these questions here that we're going to go over, these A, B, C, and D. And then after you do this, you're going to create your own question on your stations page. So here's A. Let's look at this one. A says natural log of x minus natural log of x minus 1 equals 1. All right, so our first step here is that we want to, well, our goal is to isolate our log, but we first have to combine these. So when we're subtracting, we know that we're dividing. So I can write it as a single log by dividing, and that equals 1. So our first one is to condense to 1 log. I can't spell today, so forgive me. Now I want to write it as an exponent. So my second step is to write as an exponent. So in order to write as an exponent, I need a subscript. So I need to remember that ln, the natural log, is the same as log base e. So I'm going to write this as log base e of x divided by x minus 1 equals 1. Now I can write it as an exponent. So I'm going to say e to the 1 power equals x divided by x minus 1. All right, so in order to solve for x, I'm going to go ahead and put e over 1, and I'm going to cross multiply here. So I have e times x minus e equals x here. So I know this looks a little bit confusing, but remember e is a number. It's that 2.7, right? But I do kind of want to put it together and do it all at the same time. So we'll do this minus ex minus ex. So this is 1 minus e here. We can combine them. I have a negative e equals, let me get my calculator out. So I want to do 1 minus e, and that is negative 1.718. So let's call it negative 1.72. And now I'm going to get rid of x's, sorry, x, forgot my x. All right, now I want to get rid of this negative 1.72. So I'm going to do this. I'm going to divide by negative 1.72 on both sides, negative 1.72. And let's see what that is. Close, go back to main, close my parentheses. No. All right, so let's see. Negative e divided by negative 1.72. We get 1.58. So x equals positive 1.58. So you're solving just like an equation. We could have done the 2.7 here and here. You don't have to leave it as an e. You can change it to a number anytime that you're dealing with it. All right, here's letter B, or second you try question. This says log base 4 of x plus log base 4 of x minus 12 equals 3. So first we want to condense, right? So I know that if I'm adding, I'm multiplying. So I have log base 4 of x times x minus 12 equals 3. Now I want to write it as an exponent. So I'm going to say 4 to the 3rd power equals x times x minus 12. All right, so I'm going to go ahead and distribute here. So I have 64, that's 4 to the 3rd, equals x squared minus 12x. What do you do when you have an x squared and an x? You put everything on one side and you try to factor. So that's what we'll do. We'll put our 64 over here. So we have 0 equals x squared minus 12x minus 64. So I'm going to either factor, or I'm going to use quadratic formula, or I can graph it and see where my zeros are. Let's go ahead and graph it just so we can save ourselves some time. So I have x squared minus 12x minus 64. Oops, 64. So here's my zeros. -4, and 16. Oh, which makes sense, right? 4 and 16 get 64, and they add to get 12. So I can factor in this way, x minus 16 and x plus 4. And then my answers are x equals 16 and -4, right? So there's my answers right there for letter B. All right, moving on to letter C. We have log 5 of x plus log 5 of 2x minus 9 equals 1. All right, so my first step is I want to condense. I'm adding, so we're going to multiply. So we have log base 5 of x times 2x minus 9 equals 1. Now I want to write it as an exponent. 5 to the 1 power equals x times 2x minus 9. Looks a lot like the last one. I'm going to go ahead and distribute the x here. So I have 5 equals 2x squared minus 9x. It's an x squared and an x, so I'm going to put everything on one side and try to factor. So I have 0 equals 2x squared minus 9x minus 5. Great spot for me to try to graph this and see where my zeros are. So 2x squared minus 9x. This is always a lifesaver for me, especially if I don't want to spend too much time on one single problem. So there's my answers right there. X equals 5 and -0.5. Okay, so those are my two answers. Now we're going to go back at the end to see which ones might be extraneous solutions. Remember, you always have to check your answers, and we're going to do that by graphing, and I'll show you how. Well, you learned it during the notes. All right, letter D, we have 2 times log of 11x minus 12 plus 1 equals 3. This one's a little bit trickier. Oh, you can't see it. Because it's already in one log, but we have some extra stuff here. So I have an extra 1 here. I'm going to move that to the other side. So I have 2 log times 11x minus 12 equals 2. And then I'm going to go ahead and get rid of this 2 by dividing. You could move it to the exponent, but you don't have to. We can go ahead and divide it like this. We can follow our algebra rules. So it equals 1. All right, remember, if there's not a subscript here, it's a 10. So now we're going to write it as an exponent. So I have 10 to the 1 power equals 11x minus 12. So 10 to the 1 power is just 10 equals 11x minus 12. No factoring needed on this one. I'm going to add 12 to both sides. We get 22 equals 11x, and it's going to end up being a beautiful even number. I love it when that happens. All right, I'm going to plug these into the calculator. I'm going to pause and plug these into the calculator so we can see where the intersection points are. Here's the our A example here, and here's my one side. There we go. There's one side of the equation. So if you plug in one side as a function, you can kind of see it there as the green function. And then if you plug in the left side as y, or the right side as y equals 1, then you can see that their intersection point is this 1.582. That's exactly what we wanted because that's what we got as our answer, 1.58. That's good news. Right, so this one is a really good example of an extraneous solution. So our solutions here were 16 and -4, but let's look at our actual graph. Here, the black graph is the left side of the function, log base 4 of x plus log base 4 of x minus 12. And then the right side is, or the red graph here is that y equals 3. So notice that we do have an intersection point at 16. That's great, we got the right answer. But we have an extraneous answer here, -4. So what I'm going to do here is just say this one is going to be extraneous. So remember, always check your work on these because it's not no solution, right? It's an extra solution. So you have to make sure to write both answers, but 16 is your real answer and -4 is your extraneous solution. So please go ahead and do the same thing for the last two and see which ones are extraneous and which ones are real.